Hey, you want a crouch tutorial? Here you go, big guy. Here's a crouch. Here you go. You're done. Get out of here. It's over.
Hello everyone, and welcome back to another CRYENGINE 5.7 LTS video tutorial in our ongoing series about C++ and creating a playable character. In this tutorial, we're going to be going over some refinement techniques so that we can make our code much easier to read, and then we're going to be adding some crouching capability for our player. And so that we're all on the same page, we are using our code that we've been building throughout this C++ series. So if you're wondering where I got this code from, well, you can watch part 1, part 2, and part 3 and get all caught up. And we also want to make sure that we are all using CRYENGINE 5.7 LTS. For our programming, well, I'm going to be using Visual Studio 2017 throughout this tutorial. However, you can use whichever version of Visual Studio you have or you prefer, whether that's 2022 or Visual Studio 1811, which it's a bit slow. So let's get started. We're going to be opening up our solution, specifically our Player.h and our Player.cpp that we've been modifying throughout the series, and we're going to start with cleaning up our Player.h. As we open this up, you can see in our Player.h, well, it looks just like it did when we left off from our jumping, so let's dive into these changes. The first change that we're going to do is move the enum class underneath the C player component. So right now it's kind of a bit separated from the rest of our code, which it'll still work, but we want to make a public class right up here at the top under the C player component. We can just copy and paste our ePlayer state and our walking sprinting scope just underneath that, and then just make sure that that's, again, in the public class. If we add more player states later on, which we will with crouching, it just makes it easier to see what is what. And if we scroll down, well, we can just start snipping out a few things. Our M movement speed, we can just get rid of that from our add member line here. And we can also snip out this M camera default pos. Since we are moving them from our add member, we of course want to go down at the very bottom to our private class here and just snip them out. So, all right, we can just yeet these out of here. Vec3, camera default pos, yeet. Float and movement speed, yeet. All right, those are gone. We're going to be replacing these actually with better named variables. So let's go ahead actually and just replace our old M camera default pos that we just yeeted out into the nether. Vec3, camera offset standing. And of course, that's a Vec3 because it's a camera and we're dealing with three-dimensional axes here. So let's scroll on back up here to our add member line, and we're just going to copy an existing add member line, and we're going to paste it right in here, and we're just going to rename things for our camera offset standing. So for the add member component property, we'll put that in here, and camera offset standing. We'll just put this ID as cam S for cam standing. We'll do camera offset standing in here. And again, camera standing offset, I guess we could just make that, and then at the very end for the definition, we'll do offset of the camera while standing. And for the very end here, we'll just do vec3 0f 0f 0f, so 0 on all the axis, which would just default it to an undefined default position at this point. But we do want to further refine how we approach these values, because currently our default values are undefined. So when we load up this project, our camera default offset standing will be at 0 on all the axes. And while we could add a 2 here at the end of our vec3 on the z-axis, you know, and give our camera a 2 value, so it would be the height of 2. This would only show up in the inspector, so it would only show up in the properties window of the entity, of the player entity. And depending on how you're editing your game, you might also want this to show up in schematic, right? So if we set this here as a default value of 2, it'll be default value of 2 in inspector, but if you open this up as an entity in schematic, well, that won't carry over. So that also kind of can open up for some conflicts, and we just want to make sure that we can define our default values in both the inspector and schematic editor. To do this, well, underneath our newly created public class containing our ePlayer state and the scope, we're going to create a new private class right underneath it. And within this private class, we want to create a static const expression float. And after this, we're going to define the name of the value and then add the value that we want for the specific value name that we've defined. So, for example, if we want to add a default value for our default walk speed, or default speed walking, I'll just name it, will equal 3. And then if we go down here to our add member for this speed, this walking speed, we can just copy the default speed walking that we've defined up here in the private class and paste that instead of 0. So we won't paste 3 here, we'll actually paste the name that we've defined for the value. And just like that, our default walking speed will have a set default value of 3, whether we want to edit our player in the inspector or within schematic. And simply put, we need to do this for each of these add member lines. So everything that we want to define a value for, we just do this where we do a static const express float. We'll do default speed running, and we'll, make that equal 6, so twice our walking speed. And then we go down to the relevant add member line here, and at the very end of our m_run speed, we're going to replace the 0 with our default speed running. And this goes on, right? Because we have our jump height. I'm going to do a static const expression float, default jump. I'm going to name this default jump energy because default jump height can be a little bit misleading. Say you have a game and there's a level that takes place on the lunar surface of the moon. It's not going to really be the jump height, right? If you set the jump height to 3, well, you're not going to be jumping consistently as if you were on the previous level where you're on Earth. So I think default jump energy is a bit more of a better specific name for this. And then we'll make that equal 3. And then we will paste our default jump energy into the value for our jumping add member. So we'll go back up here and we'll add another static const expression float, and we'll do default rotation speed. And this, of course, we want to be a very low number because, it's a very sensitive mouse value. So 0.002. And then we'll paste that one right down into our rotation speed. Then we'll do another static const expression float, and this will be for our new one, so our default camera height standing. And we'll set that to a value of 3, and we'll just copy this default camera height standing name here and paste that. Now, where we paste this, this one looks different than the other ones, right? This is a vec3, but it's camera height, so it's going to be on the z-axis, which means we just paste it. We replace this final 0 here, so 0, 0, and then for the last default camera height standing, which will equal 3. Then we're going to do a static const expression float, and we'll do our static const expression float default rot limit pitch max, and that will equal 1.15. So 1.15, and then we'll copy that and paste that one right into our max. Default rot limit pitch minimum, and that will equal minus 0.9. And we'll paste that one in to our add member for our rotation limit minimum. We do want to add one more, but it's going to be a bit different. It's going to be for our player state. So static const express, and this won't be a float. This will be ePlayer state. So static const expression ePlayer state. And then we will do default state for the name. And that will equal, well, it won't equal a value, right? Because it's a player state. So equal ePlayer state walking, because we want our walking to be our default. I guess you could say it's a default value, but we want our walking to be our default. So we'll do that. This one we won't paste into the add member, right? Because it's, well, not an add member. It doesn't have an add member line. So we can just add that one to here. So that's good. We've defined our values, and they will both show up in our inspector, and they will also show up in our schematic editor. So that's awesome. We have uniform values across our entire project in the engine. Now, with those values defined, we've only defined the values, but we also want to finalize the process of setting up our default values within our header. So we want to set our C player component down here. You can see that our C player component is set to default, but that's not going to be helpful in our case. We want to set this to override here. So we'll set that to override. Having this set to override means that we can, have a constructor that defines our variables now. Variables. All right, great. Now, before we move over into the CPP and finish off the process of setting our default values, we want to do a little housekeeping here so that, it's not such a mess at the bottom. So we have a lot of variables, runtime variables, and component properties, and they're currently a bit mixed, and it can be a bit difficult to see what is a runtime variable versus what is a component property. So to make things a bit more clear here, I'm going to go ahead and add some comments here to make it very clear what is a runtime variable. So we have our runtime variables here. We are just going to reorganize these a little bit, so a little shuffle of the deck here. Then I'll add a comment for our component properties, and we'll have our component properties here. And it wouldn't be complete without a error on build. So this is just a little error here, a little typo, a little misplaced. And just for fun, I'm going to add a comment up here for our component references. We can also remove this mlook orientation from the private class here in the header. That can get snipped. Since we've clearly defined our runtime variables, well, I'm going to add 2 runtime variables now. Since we yeeted our default camera pass into the void, I'm going to replace that now with a quaternion m_current yaw, and then a float m_current pitch. And these are going to be 2 variables for our camera positioning. However, the logic itself for our camera is going to be much shorter once we get into our CPP when we implement these. So our camera logic is a bit long right now, which was perfectly fine when we made the character, but since we're going to be adding more and more things to this, it's always helpful to simplify things if you can. And unlike our previous camera default pass, well, we don't need to add any kind of add member line for these new variables. We want to remove this player movement function here, not because we're, going to be removing player movement, but we're going to be renaming this function to something a bit more specific and to match the other functions that we want to organize. So let's just move this initialize input into our protected class. And we also want to add our reset in here. So let's just put reset. And okay, so this is looking good, and we want to also add some functions here. And why we want to add these functions? Well, if we look at the logic and how it's set up currently in the CPP, it was really nice for when we created this player, we kind of got used to everything. But as we add features, we want to make sure that these are easily defined. So it's really hard to tell where mouse looking begins and camera, position ends, and there's a lot of similar lines and et cetera, et cetera. So we can just make this easier. We are going to add some functions with some very clear names. We're going to specify specifically what these are, and we're going to add void update movement, void update rotation, and void update camera. And those are going to be the 3 core pillars of our player's logic that we want to split up and specifically define and put them in their own tiny little houses. So we'll have those 3. We also want to add a 4th one here, the last one, and this is going to be called void recenter collider. This recenter collider here is going to help us so that when we spawn our entity into the game, the center of our capsule isn't in the ground, and sometimes that can make it so it defaults back to a cylinder shape even if you want a capsule. So this is just a little help, a little bug fix. With all of those set, we have our new functions, we have our add member, we added new runtime variables, and we have our new values up here. So this is looking good. We can hit Control-Shift-S and save our header, and we can mosey on over to our Player.cpp. So we've moved on over here to our Player.cpp, and this is untouched since our jump tutorial, but since we modified our header a bit, we have a few errors, but that's okay. We'll fix those. In our header, we forward declared our new default values that we want, both in our inspector or schematic editor. Now, we can go ahead and create a definition. So this definition's name will be CPlayerComponent, CPlayerComponent, and we can begin to add our variables followed by the function body at the end. For example, we'll do m_p camera component, and at the end for the function body, we'll do a null pointer, and we can continue to add the rest of these. So m_p input component, that'll be a null pointer. Then we'll do m_p character controller, which is also a null pointer. Next, we'll do m_current yaw, and this function body will be an identity. And the next one we'll do m_current pitch. The function body will be 0.f. And just to be clear here, these all have different function bodies because it depends simply on what kind of variable it is. So if it's a bool, or if it's a vec3, or if it's a float. The next one we'll do m_movement delta, and the function body is 0. Next, we'll do m_mouse delta rotation with a function body of 0 as well. Next is the m_current player state, and this is a player state, so the function body is default state, like we defined in our header. Underneath that, we'll do m_camera offset standing, which, if you remembered, is a vec3, so our function body will be vec3, 0, 0, and then our default camera height standing. After that, we'll do m_rotation speed with a function body of default rotation speed. And the rest of these function bodies are just going to be the names of the values that we've defined. So m_walk speed with a function body of default speed walking. m_run speed with a function body of default speed running. Default jump energy. And then we'll do our rotation. So m_rotation limits min pitch. Default rot limit pitch min. And then finally m_rotation limits max pitch. Default rot limit pitch max. And then we'll just have an empty scope here at the very end. And that's it. So we have finalized our values, our default values, and now they will fully show up in our schematic editor and in our inspector. We forward declared it in the header, and now we have our definition. So this is some good stuff. So with our values all defined, everything is peachy keen, we can now clean up and modify how we're using our reset, because currently, if we go down here, we can see our current reset is now, it's an E event, which means that we can only reset variables that we put right underneath it down here. However, if we decide to make even more and more code and we want to modify this character until the cows come home, well, we don't want to just keep stuffing stuff underneath this reset. So it served its duty well. Thank you, E event. Thank you for your service, but we're gonna get rid of you in a second here, because if we go underneath our CPlayerComponent initialize and scope, and right after that, we're just going to add one for our reset. So we'll do void CPlayerComponent reset. And we'll create a scope. And we'll copy some of these existing variables from our reset, our old reset, specifically our m_movement delta and our m_mouse delta rotation. So let's copy those from our E-event reset, and we'll put them within the scope of our new reset. And we also want to make sure that we reset the new m_current yaw and m_current pitch so that our mouse orientation resets. So we'll put those in the scope as well. And for our current yaw, well, it's going to equal a quat, and we'll do create rotation z. And within the brackets, we'll do mp entity get world rotation. And what does this return? Well, we want to access get rot z, or get rotation z. And we'll finish that off and we'll end it. We'll close it out. And that's going to be it for the current yaw. The current pitch is even simpler. We'll do equals 0f. And that's going to be it. So we've reset our controller input data, and we've also reset our mouse rotation. Next, we want to put our initialize input into the reset here. So we'll just put that in there. And in our E event reset, we have our look orientation, but we took that out in our header, so we could just delete that, and we can totally delete our old entity reset and the scope entirely, and we can now utilize our new reset. And rather than putting a bunch of stuff in our E event reset, now we can just put this line reset into scopes that we want to reset. So for example, our initialize, if we go up to the initialize, we can just add a reset, and that'll be it. So our initialize will reset now. We also want to make sure that we add our player state here to the reset. We want to make sure that we always reset the player state. And with that, our reset is Gucci main here. We can now move on to the recenter collider, which I touched on in the header. So let's kick that off and add our void cPlayer component, recenter collider, and a scope. And within this scope, we are going to create a really simple if statement that will skip the next physics change in case we trigger one within the same scope here. It will cause an infinite loop. That'll make sense when we add the final line here. So let's get started. We'll do a static bool skip equals false. And if skip. Within a scope here, again, we'll do skip equals false, and we'll just return it. Next, we want to get our character controller up. So auto p character controller, which will equal mp entity. And we'll do get component. And then within here, we want to define cry default components, c character controller component. And then we're going to make the if statement for this once we close it. And the if statement for this is simply if p character controller, if equals null pointer, then return. Right underneath the scope of this if statement, we'll do const auto with a reference, and that's going to be for phys params, or physics parameters, which will equal p character controller get physics parameters. And then underneath this, we'll do float height offset equals phys params, and we'll be returning m height times 0.5. So now we want to create another if statement. We will clarify that the capsule is actually half height plus radius, so we do some extra calculations here. We'll do if, and then within the brackets, we'll do phys params, and we'll be accessing the m_b capsule. And within this scope here for the if statement, we're going to do height offset equals height offset times 0.5 plus phys params. And then we'll be accessing the radius, or the m radius, and we'll times that by 0.5. Now, unlike the line above this, in this one, we actually are, accessing the radius, and then we're timesing it by 0.5. What does a radius have to do with anything? Well, if you think about it, a capsule is actually a cylinder, but it's also a sphere, right? It's a sphere cut in half, and then you have a cylinder with each half of the sphere one on the top and one on the bottom. And that's going to be why we're including the radius in this calculation here. Next, we want to set the component local space z value to our recenter collider, and this can be done with a _p character controller, set transform matrix, and then we're going to do a matrix 3-4, followed by identity, and then we'll do a vec3 with 0, 0, and then we're going to do 0.005f plus height offset. Next, we want to simply skip the next physical type update since we will be triggering one in this following line after this. So this will just be skip equals true. And finally, we can tell the controller to rephysicalize, which is going to set the height collider offset to the component local space z value, and this rephysicalize is why we are adding the first if statement. So the one that we added at the top of this scope that I mentioned, we didn't want to cause an infinite loop of rephysicalizing. And that will be it for our recenter collider. So yeah, now our capsule will be always going to be a capsule if you want it to be. It will now never default back to a cylinder if the game resets and your character clips through the ground or some other bug comes up. So we have a consistent capsule now. So we can keep scrolling, we'll keep scrolling, and we can move on down to the get event mask scope, and we're going to add 2 new e-events that we're going to use here after this. These are going to be editor property changed here. So this is going to be when entering and exiting game mode or modifying properties in the editor. And the second e-events that we're going to add here is going to be physical type changed. So whenever the entity physicalizes or dephysicalizes, it's used to recenter the capsule. I'm also just going to clean these up here. So I have these all on one continuous line, which is totally fine. However, as I am adding these here, I'm thinking that, you can keep adding these and keep adding these, and even though you can add them on one line, if we add 10 more in the future, it can just become kind of difficult. So I'm just going to put each of these on its own line. With that done, we can move down to our process event, which, as you can see, is there's a lot going on here, but we want to clean this up. So we're going to actually move most of our logic for our player into the update camera, update movement, update rotation that we created, those functions. So to get started, we'll do our gameplay started. We can actually just have reset in here since we added a nice reset up top that we can call upon. Well, we'll call upon it here at gameplay started. So just put reset. And now within our e-event update, well, we can delete all of our existing logic here since we've added our 3 new functions in our Player.h that we plan on putting our refined logic into after. So in our update now, we can just have our update movement, our update rotation, and our update camera. And that's going to be it for our update. Now we want to add our physical type changed as an e-event, so we put our recenter collider within it. So case, cry, entity, e-event, physical type changed. And then we'll put recenter collider right in the scope. And we also want to add our editor properties change. So case, cry, entity, e-event, editor property changed. And there won't be a scope for that. We're just going to put reset within the scope of our reset. So that's it for our process events. And now the fun begins, because now we can just refine our existing logic. Let's create a definition for our update movement. So void cPlayer component update movement, and we'll create a scope for that. And we're actually going to copy the existing logic within the scope of our player movement and just paste it into our update movement scope. So the player movement definition can be deleted once this is done here. because we'll be using our update movement from now on. Now, while the scope of the update movement is going to be entirely with code that we built previously, we want to make our update rotation definition, so void cPlayer component update rotation. And within the scope here, we're actually going to not be copying or pasting anything. We're just going to be making code that is much more friendly for our mouse rotation. So to get this kicked off in the scope here, we can now accumulate input by doing m current yaw with a multiple and assignment operator, which will be a quat, a create rotation z, mouse delta rotation dot x times m rotation speed. Then we can set the entity rotation, so mp entity set rotation m current yaw. And that's going to be it for the update rotation. So it's much shorter and much easier to approach than our existing rotation, which again, at the time, served us duly well, but we also want to keep refining as we go. So let's move on down here to the update camera, void cPlayer component update camera, and we'll create a scope for that. And within the scope, we want to set and update the camera pitch and offset. So it's going to be m current pitch equals CRYEMATH clamp m current pitch plus m mouse delta rotation dot y times m rotation speed, m rotation limits min pitch, and m rotation limits max pitch. We'll close that out. Then we'll do a matrix 3-4 final cam matrix. And we're going to do final cam matrix, which will access set translation. And that'll be for m camera offset standing. Close that out, and on the next line, we'll do final cam matrix, and we'll access set rotation 3-3. And this will be a matrix 3-3 here. So matrix 3-3, create rotation x, and we'll do m current pitch. So m underscore current pitch, and we'll close that off. And finally, for the last line for our update camera, we'll do mp camera component, get transform matrix, and final cam matrix. So that's it for our update camera. Our camera is now looking fine. And if you compare this to our code that we used to have, well, it's a bit shorter, of course, but also it's much easier to read. So you can look exactly where the update camera is, where the update movement is, and where the update rotation is. And I encourage you, when you build this and you keep building this, to keep this kind of structure up. So, say you want void cPlayer component update Ds, you can put that in there. So you can always just keep adding them and keep it structured. And that's going to be it for our refinement, actually. That's all. We've done it. You can Control-Shift-S, save that bad boy out, and then build it. And if you get any errors, well, good luck. Just kidding. Of course I'm kidding. If you have any errors, there shouldn't be any glaring issues, but it's always good to build even before we move on to crouching, just to make sure there's no typos or misplaced commas or anything like like this little guy here. Yeah, always remember to close your brackets, kids. With that complete, I've got a nice healthy build here, nice girthy build. I'm going to hop back to the Player.h. With our code built and refined, we can move on to the fun part here. Not to say that the previous part wasn't fun, but let's be honest, adding crouching is going to be a bit more exciting because, well, we get to see some cool results from it. So to get this started in the top of our Player.h, we can simply just add a namespace here, and this namespace is for primitives, and within the scope, we'll just do struct capsule, and this will be under here, underneath our pragma once, just right at the top, and this will be used later. We want to make sure we have this ready here, because this is going to be for our PWI test, which we'll be experts on once this video is over, but just for now, we'll just add this namespace primitives struct capsule. Now, moving down here, well, we added our player state to the public class, which is perfect because, well, now we're going to add a new one. So within this same public class, we'll do enum class ePlayerStance. So not ePlayerState, we're going to do a new one just called ePlayerStance. And within the scope, we'll do our player stance, standing, and crouching. Now, going in the same order as our refinement, well, we could start modifying our forward declaration here, but really quickly, I just want to add a bunch of our new variables and our component properties. So we also want to add our player state, of course. So we go down to the bottom here in our private class. Under our runtime variables, we want to add ePlayerStance, mCurrentStance, and ePlayerStance, mDesiredStance. Underneath that, we want to do a vec3, and that'll be named m_camera_end_offset. Now, we're going to be adding some camera variables here because, well, crouching is going to be mainly driven by two things, right? We have our physics capsule that we want to change the height of when we crouch, so we can actually crouch under things if they are obstructing our way. But also we want to modify our camera because we want to match our camera height with our crouch height. And with the changes here for our camera and our capsule, we're going to need to add component properties to reflect this. So we want to add some properties that define both the capsule and camera height when standing and crouching. And to get this kicked off, we'll do a vec3 m_camera offset crouching. Now we'll do a float m_capsule height standing, followed by a float m_capsule height crouching. And of course, we'll end that bad boy off with float m_capsule ground offset. So that's going to be all that we're going to add down here. As you can see, we have our component properties, we have our runtime variables, we have our friendly component references just chilling up here. So with our runtime variables and component properties defined at the bottom, we can now add them to our forward declaration. So just like when we refined it, we'll add, well, when we did our refinement, we added this default camera height standing, and I named it as such because, well, now we're going to add our default camera height crouching. And I'll set that to a value of, I'll just do 2.2. And now we have to do our capsule. So underneath this, we'll do our static const expression float default capsule height standing, and I'll set that to 1.6 just so that we can see the difference between the camera and the capsule height at first when we load up our character. And underneath that, we'll do one for crouching, so default capsule height crouching, and I'll just set that to 0.75. So we have our capsule, we have our camera, we have them both set to a crouching and standing value. And then now we can just add our default capsule ground offsets. And I'll set that to a very low value. I'll just do 0.2. And this is just to help us so that our capsule, when we recenter it, it also has us off the ground a little bit so that we don't have any friction, so we can glide across the landscape. And of course, at the very bottom here, we want to add our new player state. So static constant expression ePlayerStance, and we'll name that default stance, which will equal default stance standing. So we want a default stance of standing, and just like our refinement, we'll go ahead and create some new add member lines and then define the values at the end. So we'll add one here for our camera offset crouching. And we'll just have cam_c as the ID. We'll add camera offset crouching, camera crouching offset, and for the definition, we'll just say offset of the camera while crouching. And this is a vec3 since it's a camera, so we'll just do vec3 0f, 0f, and for the final z-axis, we'll do our default camera height crouching that we defined in our forward declaration. Next, we're going to do our capsule height crouching and standing. So we'll do an add member and just copy the add member here, and we'll paste it below, and we'll do it for standing. So capsule height standing. The ID should be caps. And then we'll do capsule height standing, capsule standing height, and for the definition, height of collision capsule while standing. For the value at the end, this isn't a vec3, right? This isn't a camera, so this is just for the capsule, so we can just put default capsule height standing here. We'll do M capsule height crouching. For the ID, we'll do cap C, capsule height crouching, capsule crouching height, and for the definition, height of collision capsule while crouching, default capsule height crouching, and the very last add member that we're going to be adding here is going to be for our capsule ground offset. So M underscore capsule ground offset. Let's see why this is red. I have a suspicion I spelled capsule wrong. Capsule. So capsule. Sorry, it's really cold outside. My hands are a bit stiff from coming in. So, and then we'll do capo for the ID. Capsule ground offset. Capsule ground offset, and for the definition, we'll just say offset of the capsule from the entity floor. So I didn't want to say the ground because, right, you could be on a floating platform or in a spaceship. So the floor relative to the entity. Default capsule ground offset. And that's it for our add members now. We've added all the lines that we need to prepare for our crouching. Now, the very last thing we want to do to prepare our Player.h for crouching is to add functions to our protected class that we will be using in our CPP. The first function we want to add here is going to be void, and we'll name this try update stance. And this is going to be where we add all of our juicy, delicious crouching logic in our CPP. Next, we want to do bool is capsule intersecting geometry. And this is just a bool because it's either, it's checking if you are intersecting it or not. But in the brackets here, we want to do const primitives capsule. And we want to specify capsule. We'll have a const, and then we'll just close that one out. And the last thing we're going to do here for the Player.h is just add in between the brackets for our update camera. We want to add float frame time. And we didn't add this before because, well, we didn't use it for anything, but since we're going to be modifying our camera, or update camera, for when we crouch, we want to get it ready for float frame time, which we'll get into in a second here when we do our update camera logic. And that's going to be it for our Player.h. We can hit Control-Shift-S and save that puppy. And I'm going to open up the Player.cpp here, and we're going to get cranking on adding this crouch. So in the same order as our refinement, let's add our variables and function bodies to our definition. So let's make some space here, and we'll do m underscore current stance. And since this is being driven by our ePlayer state, well, we're going to do default stance in our function body. And below that, again, we'll do m underscore desired stance with a function body of default stance as well. Now, the next few are going to be for the camera, so they're going to be vec3s. We're going to do m underscore camera end offset, which is a vec3, and we'll do 0.f, 0.f, and for the z-axis, we'll do default camera height standing. Next, we're going to do m underscore camera offset crouching, and this is our last vec3, so we'll do 0.f, 0.f, and we'll do default camera height crouching. Let's move on to the capsule here. So m underscore capsule height standing with a function body of default capsule height standing, and m underscore capsule height crouching with a default capsule height crouching function body. And we'll finish this off with m underscore capsule ground offset with a function body of default capsule ground offset. So I will move these back together, rejoin them to the new big family they are now a part of. And we can see here, well, we have our definitions all squared up. So let's scroll on down here. In our new refined reset, we also want to make sure we add our desired and current stance variables. So right here in the scope of reset, let's add M current stance, E player stance, standing, and our M desired stance equaling M current stance. So that will reset our player stance. And lastly, for our reset, we want to make sure that the camera lerp resets the position to the standing position. And the camera lerp, well, that's the first time I'm mentioning it in this video. I'll get into that in a bit more specifics again when we do the update camera, but it's just going to be a linear interpolation that will help us achieve a very smooth camera when we go from crouching to standing or standing to crouching, rather than a very jarring, seemingly teleporting camera between the two player stance states. And we can achieve this by doing M underscore camera end offset equaling M underscore camera offset standing. So that will reset the camera alert position to standing. We have our reset input controller data looking lovely, and we also have our reset of our player states. So that's good. Our reset is polished, and let's add the input. So if we scroll down here even further, we can see our initialize input with all of our inputs in it. And our input for crouching is going to be very similar to our sprinting and walking input. So it's going to be a bit different, but I just recommend copying and pasting everything in between this register action and bind action line from the sprinting and walking, and just pasting it. And I'm going to paste it down here right above our mouse because I don't want to separate our key inputs from each other. So we have all of our key inputs together, and we can just start making the changes that we need to match what we want for our crouching. So instead of sprint up here, of course, we want crouch. We also want to put M desired stance in here. We want to change E player state to E player stance, and we want to change this to crouching. And below here, we'll do the same thing. So M desired stance equals E player stance, which will be standing. And then for the bind action, we'll just say crouch. And for the actual EKI, we're going to do left control. Let's do left control. I like left control. For the people who like to use the C key as a crouching button in games, let's chat. Let's chat after the video. So let's move down to the process event, and we want to add our new function. So try update stance. We'll pop that in there. And we also want to add float frame time to our update camera function to prepare it for the lerping that we're going to add. So we'll squeeze that frame time into the update camera, but also up top here in the scope, let's just do a const float frame time equals event. And we're going to be getting the F params. We'll just put parentheses with a 0. That's going to be it for the update. We can move down even further, and we can actually implement this lerp. So we've only done some preparing for the lerp with all of this frame time, and I know that's been a little bit confusing, but let's break it down. Let's add our lerping. We're going to go in here to our update camera, and at the very end in the brackets of the actual update camera definition, we'll just put in float frame time. And within the scope to actually implement our lerping, we're going to do vec3 current camera offset equals MP camera component get transform matrix. And what does it want to access? Well, we're going to return the get translation. On the next line, we're going to do current camera offset equals vec3. And we're going to here create lerp. So vec3 create lerp, yay. And within the brackets, we'll do current camera offset M underscore camera end offset. And we'll do 10 works, so 10.0f times frame time. Now, this 10.f times frame time is kind of the conclusion to adding all of this frame time around our header and in our definitions. What this means is that no matter what frame rate you're getting, if it's, 20 20 frames or if it's 120 frames, the smooth lerping of the camera when you crouch or uncrouch will remain smooth. It won't be jittery. It won't, you know, as long as you don't have 1 frame a second, it should be good. So this is just taking the frame time. And the 10 here is actually going to be the speed at which the camera lerps when we crouch. So you can always play around with this number. You know, if you want to have a quicker camera movement when crouching or a slower one, you can modify this. And that's going to be it for the lerp. So we've just created the lerp. Awesome. Let's dive into the beefiest part of this, which is going to be adding actual crouch function to our capsule to coincide with our wonderful camera lerp that we've added. So let's create our new definition, and the logic for our actual crouching for our capsule is going to be underneath our new friend, the try update stance. So let's create a definition for that. We'll do void cPlayer component try update stance, and we'll create a scope. And first, we want to create a simple if statement within the scope that is going to simply check to see if the desired stance is the current stance, and if so, well, there's not going to be any change needed. So we'll just do if m_desired stance, if equals m current stance, return. That's it. Good job. I'm proud of you, son. Next, we will ensure that we prevent a crash if the physical entity is not available during the update. We want to add this I physical entity, and then we're going to grab the physEnt, which will equal MP entity get physical entity. And by adding this line now, we can add our if statement with our pphysEnt. Another simple if statement, so we'll just do if pphysEnt. If equals a null pointer, and then we'll just return it. Now we need to get the radius from the character controller component properties, and we can get these by doing a const float radius equals MP character controller. We'll do get physics parameters. Then we want to access the m_radius times 0.5. Underneath that, we'll do a float height equals 0 and vec3 cam offset equals 0. So that will help us get the radius from the character controller component properties. Next, we will create a switch to lead us into the case for our ePlayer stance. So we're just going to do a switch within the brackets. We're going to do m_desired stance. So for the crouching, we just need to simply set the necessary values. And this is going to be a case because we have a switch. So let's do our case here. ePlayer stance crouching. And this is going to be pretty simple. It's just going to be height equals m capsule height crouching, followed by cam offset equaling m camera offset crouching. And then we'll just set a break at the end of the scope here for the case. So standing is going to be a bit different as we want to stand, so we set the values here, but if the check fails, we return without updating the data with these values. So we'll do case ePlayer stance standing, and similar to our crouching, we're going to do height equals m capsule height standing, and then we'll do cam offset equals m camera offset standing. But below on this same scope, we want to check to see if we can stand here using a PWI world intersection test or a PWI test. And after we do this for our crouching, I'll get into the PWI test more because that's going to be the final thing that we add. So for now, we're just going to do that quick check. And first, we create a like-for-like copy of the living entity physical capsule while standing. So we're going to use that primitive that we added way at the beginning of this within our header. So we'll just do primitives, capsule, capsule. Then we just want to specify that, well, it's a vertical axis, so on the z-axis. And to do this, we're just going to do capsule, axis, capital S, make sure it's a capital S in set here. And within the brackets here, we're going to do 0, 0, 1. So 1 on the z-axis will specify it's a vertical capsule. Next, for a capsule center point, we calculate the offset plus the radius and the half height. And this can be achieved with a capsule center equal MP entity get world position, or POS, get world POS. And we're going to plus vec3, which will be 0, 0. And the z-axis is m capsule ground offset plus radius plus height times 0.5. And then we can define the capsule a bit more here. So we'll do capsule radius equals radius. And we'll do capsule.hh, which stands for half height. And that will equal height times 0.5f. And lastly, if the capsule would intersect any other physical geometry, we want an early return. So is capsule intersecting geometry? And then we'll put capsule in the brackets here. We want to return it. So in the scope, just do return. Make sure that we have a break here after our standing, and then we'll stay in the scope of our try_update stance. And we want to update the capsule data for the physical entity. So to update the data, we're going to do PE player dimensions, capital D, make sure, and then we're going to close that. And underneath it, we'll do P physical entity, get params, and then we're going to want player dimensions. So it's going to be calling on the player dimensions here. For the capsule center point, we want to calculate the offset that we created plus the radius and the half height. So player dimensions, and we'll be accessing the height collider, which will equal m underscore capsule ground offset plus radius plus height times 0.5. And the size collider is a simple radius with the half height. So after this, we're just going to do player dimensions size collider equals vec3. And within this vec3, we're going to do radius height times 0.5. Next, we want to ensure that we use the camera alert between crouching position and standing position, and this is simply m camera end offset equal cam offset. And if everything is good, which we hope for, we want the current stance to equal the desired stance. So after this, we'll do m underscore current stance equals m desired stance. And lastly, we want to set the data on the physical entity. So we can do this with a simple p physical entity set params or reference player dimensions. And that is going to be it. That's the logic for our crouching. And before we test this, we need to do one more thing. This technically will work just fine with the camera and the crouching, but you'll find that, yeah, when you crouch under something with this logic and you let go of the crouch button, it won't know if you're under something or not. So you'll either clip through it and get stuck, or your new height will be defaulted to the crouch height, and just weird stuff happens. So we just want to write a quick PWI test and define it so that we can avoid that. And with this test, it'll be really nice, because if you crouch under something and you come out from underneath it, well, if you're not holding the button anymore, it'll automatically detect that you're not under something and you'll stand up automatically. To get this one kicked off, we're going to do a new definition at the very bottom here, and this is going to be a Boolean C player component is capsule intersecting geometry. And within the brackets, we're going to do a const primitive capsule, and we're going to want the capsule, and we'll end it with a const, and we'll create a scope for this. And within the scope first, we just want to prevent a crash if the physical entity is not available during the update. So physical entity, we'll point it to p physical entity equal mp entity with a get physical entity. And we'll close that, and underneath the if statement, we're going to do if p physical entity, if equals null pointer, return false. And for a PWI cast, we need to fill a data structure. So to do this, we're going to do I physical world, SPWI params, PWI params. And we'll close that off and we'll start to define the data. First, we want to get the type directly from the primitive argument passed to us. So PWI params I type equals capsule type. And underneath that, we'll do PWI params P prim equals a reference to our capsule. So that's going to be the first part of our data. Next, we want to skip the player's physical entity. Otherwise, we will always interact with ourselves. So that's not a good problem to have. And also, say you're holding something like a gun and it has a physics proxy on it, or you pick up a box. Since this is a pointer-to-pointer array, we can actually use a vector and point to a pointer to the first element. So, for example, since we just have a single physical entity to skip, we just passed a pointer to the physical entity pointer. And this looks like pwi.pskipEnts equals a reference to p physical entity. And underneath that, we'll just do PWI params and skipEnts equals 1. Now with a PWI, you can always sweep across a length. And this is really useful, for example, with a camera collision. In that case, you would sweep a sphere from the closest camera point to the furthest and place the camera in the contact point of the sweep. This would prevent the camera from being obstructed by physical objects like walls, or, it would just keep it so it's not blocking the view of the player or clipping through the wall. In this case, we do not need a sweep test, so we can just disable that altogether. And to disable that, we'll just do intersection_params, intersection params. Underneath, we'll do intersection params with a B sweep test equaling false. After that, we'll just do a PWI params.pip, which will equal a reference to the intersection params. So now we can do the actual PWI test. Since we've defined it, we can do the actual test, and the return value is going to be how many physical entities the primitive is currently intersecting. So we'll do const int contact count equals static_cast. We'll have an integer, and within the brackets here, we're going to do the G environment, P physical world, primitive world intersection, and within the brackets, we're going to do PWI params. At the very bottom, the very last line, to conclude this, we're going to do return contact count less than 0. And we'll close that out. So that is going to be it. We want to Control-Shift-Save. Let's go through this, make sure everything is in order. This is all looking good. I guess, yeah, maybe we should put our try update stance before our updates. I don't think putting our try update stance before our updates will make any noticeable difference at all. It'll probably work just fine, but the only thing I can think of is by having our try update stance before, it means that our crouching will update before the movement is calculated and before the camera is calculated. So whereas having this after the updates, if we hit crouch, the key press is detected on the frame and then the movement logic happens. So we crouch one frame later. So I don't think this is going to make a huge difference, but, we're gamers and every frame counts. So yeah, we'll just pop that up there. Everything else is looking excellent. So we can Control-Shift-S and then we can also build. So let's make sure that we're in debug mode here for when we build and test our code. So debug mode, and then we'll hit Control-Shift-B to build this out. Let's see if there's any errors. Oh, we just got this little one. My hands are still a little bit cold, so let's fix that little typo here and build it out. Everything is looking good. That's a nice girthy build. And now we can test this in CRYENGINE. So let's test this out. We're going to open up our CRYENGINE 5.7 LTS and give this a go. So we'll load this up, and I got my level open, my floating cube of terraforma in the sky. I'm going to find a nice little fluffy patch of grass here and place an empty entity. And we'll add a component, and we want to add our C player component. And right away, you can see our capsule, you can see our camera, and we can adjust all of these heights and widths of the camera and the capsule. But if we scroll down here in the properties of the inspector for our player, you can see that we have our defined values. And if these are a little off, you know, depends on your game, whatever kind of game you're making, the size of your world, you can always modify these default values. So, you know, if this isn't what you want, of course, go in back in the CPP and the header and change it up. But we can always change it here in the meantime. So I'm going to modify, tweak my width a little bit, make it a nice wide boy. And now I'll set it to... And yeah, we can give this a test. So if we hit Control G, we can test this in our game. And as you can see, we can still jump like we added previously. We can still sprint around. I don't want to sprint off this edge because, yeah, that's really far. Yeah, so we're going to turn around and we can go over here. We have this nice little area. I can try jumping over these rocks, but yeah, I can't. I've made it so you keep sliding back. You can't actually jump over these. But there's a trick. So there's this little log over here, which previously I was not able to access, with a nice little lake over there, or a little pond, I guess. And now that we've added our crouching, let's give it a shot. You can slide right under here, and I can check this little pond out, and that was beautiful. So, yeet, yeet. Perfect. Excellent. That's awesome. We have a crouching character. If I change the camera here and I show the physics proxies, you can see what's going on exactly. You can see our player. You can see the crouching actually going on. You can see the capsule getting a bit shorter. You can kind of almost see the ground offset, but the grass is kind of obstructing that a little bit. But other than that, thank you very much. I'll see you next time, and I'll see you later, alligator.